So good morning all of you. In the last class we have seen one method for SSB signal generation. What was the name of the method? How many of you remember? Balance modulator method, am I right? So while dealing with SSB transmission, I've told you that we have three methods. First method is balance modulator. Second method is phase shift. And the third method is the third method itself. Okay, easy to remember. The block diagram and the how we are going to receive using how we are going to generate SSB signals using balance modulator we have dealt with in the previous class. Okay, in this class we will be dealing with the second method, that is the phase shift method. So this is the basic block diagram for phase shift method. We have an audio input, we have the audio input amplifier, then we are passing it through a balance modulator and then to a crystal oscillator. Now here you are mixing, actually you are mixing the signal with the carrier signal. After that you are creating a phase shift and then this particular signal is further amplified. The output signal of this particular unit is given to a summing amplifier where you add both the input and the carrier, the message signal and the carrier signal. We amplify it and we use matching networks to filter the unnecessary components. Then we transmit. This method of generation of a single sideband is called as phase shift method. Okay, SSB systems, second method of generating single sideband systems. Just for the sake of review, single sideband systems are those systems where the carrier and the one of the sidebands, either the upper sideband or the lower sideband, is suppressed and only the single sideband is transmitted because it can save a lot of bandwidth and there is so many other resources that it can be saved. Naturally, when the information is less, we need to transmit less. So we save a lot of other resources. Explanation for the block diagram. The phase shift method avoids filters and some of their inherent disadvantages and instead make use of two balance modulators and two phase shifting networks. In phase shift method, we don't use filters, instead we use two balance modulators. So far we have seen generation of SSB signals. Now we are going to see how we are going to receive SSB signals. So we are going to study how we are going to receive SSB signals and reconstruct these signals so that the original message signal is being recovered. This is a basic block diagram for a SSB receiver. The block diagram, you can see that we have a receiving antenna here. The receiving antenna feeds the signal that is being received through a radio frequency amplifier. In most of the reception circuits, you will have this RF amplifier because we wanted to increase or we wanted to boost only the required signals. The other signals should be So you have an RF amplifier in most of the reception circuits because we wanted to boost the RF components. We wanted to amplify the radio frequency components. So this is a tip for you. When you write your exams, for all reception circuits, you may usually have an RF amplifier. Then we have what is called as AGC. AGC means automatic gain control. What is gain? What is the gain of an analog circuit? Here you have something called as automatic gain control. The name tells you how you are going to control the gain. Okay, then you have a mixer with a oscillator which generates a signal. Then you have the first IF, intermediate frequency amplifier, IF amplifier. We'll see in future sessions in detail about IF amplifiers. And then you have another mixer with the same system. We have an oscillator also. Then you amplify the signal again. Then using upper sideband filters for upper sideband and for lower sideband, we have separate one. This is given to the product or the balance modulator from where you get the output signal. Okay, we take a feedback of the signal and then we proceed with the automatic gain control. From here you get the audio output. There is a possibility that you might get a question, explain with neat or necessary block diagrams, SSB transmission and reception. For your university, you may get a full mark question, a big question on transmission and reception of SSB. There are possibilities. For the last 2 or 3 question papers, you had questions based on amplitude modulation, equation and problems only. So usually you may get a change in the question paper and you may be asked to explain SSB transmission and reception in detail. In that case, you have to draw all the 3 block diagrams and explain properly. Explanation for the block diagram. The SSB circuitry is that of a double conversion amplitude modulated receiver down to the output of the second IF amplifier except for the use of local oscillators. So in the first case, IF is intermediate frequency amplifiers, and in detail we'll study what is IF or intermediate frequency when we are going to deal with frequency modulation. So the first IF has a bandwidth of approximate 10 kilohertz with a center at 2.2 megahertz. Similarly, we have an IF which also has a bandwidth. The second IF is also having the bandwidth of 10 kilohertz, but there is a difference that we have the central frequency to be 200 kilohertz down to SSB filter inputs. Now in this case, what we are going to study is intermediate frequency or IF frequency amplifiers, or intermediate frequency is a IF amplifier is an amplifier which amplifies a particular band of frequencies. So that particular band here for the first one is defined to be 10 kilohertz. Okay, and the midpoint or the center point for the first one is 2.2 megahertz. So it will be somewhere between 1.2 megahertz to 3.2 megahertz, something like that. Okay, not exactly, but something like that. For the second IF, you have still a bandwidth of 10 kilohertz, but it is only centered around a very low frequency band, that is 200 kilohertz. The band pass is wide enough to pass a normal amplitude modulated signal or including both the SSB signals. So you are creating a band which is higher than the upper sideband and lower than the lower sideband, so that the signal passes through the band pass filter. And then we use an envelope detector that could be added to the signal to allow AM reception as well as SSB reception. See, you should keep one point in mind, that it is only at the stage of transmission that you need to be too much worried about the resources. In receiver, you can receive n number of signals, right? Yes or no? So we don't need to worry too much about the bandwidth or the resources at the receiver's end. We have infinite amount of resources at the receiver's end. Only while transmitting, you need to reduce the signals. Only while transmitting, you need to be worried about the bandwidth and so on. Here, the first oscillator and the RF amplifier are manually switched tuned circuits. Of course, you can imagine that today we don't need to use SSB systems and all these things. But this is for your historical understanding of communication systems, how communication systems in olden days developed. Yesterday or day before yesterday, in the news, I saw that the last telegram, the telegraph office in India was closed. So once upon a time, we used telegram and telegraph for communication. I don't know how many of you have heard of it or how many of you have used it. Only 2 to 3 days back, it was closed. The second oscillator is a crystal oscillator at 2 megahertz, and its output is divided by 10 in digital counter to provide the 200 kilohertz carrier signal for demodulation. Another one important thing I want to tell you is that please don't blindly write notes alone. Try to understand and write. If you cannot understand any concepts, you are always free to ask me any number of times. This is a spectral diagram of a high frequency LSB lower sideband receiver. Here you can find that in the initial stage you have the central frequency. These things are not transmitted, okay? So LSB is transmitted after passing through the first intermediate filter. After the first band pass, you can get a particular central frequency, and this is the only LSB component. Now again, you are passing this through the second intermediate frequency filter, and finally you get in figure D, in the fourth diagram, you can see that all the other frequency components are eliminated and you get the lower sideband alone received. In an USB receiver, it would be the other way around. Next is a very important question that often appears in your exams. What are the advantages of single sideband systems over a full carrier double sideband systems? The bandwidth requirement for an SSB is naturally half, because you are sending only half the signal, right, than by the DSB. Since single sideband system uses all the other advantages are related to this. You are transmitting lesser information, you have more advantages. You may get a question in your exam based on this, so you need to explain this in a very beautiful, interesting language, so that your evaluator feels to give you more marks. Since SSB system utilizes half the bandwidth than DSB, the thermal noise power is reduced to half that of double sideband systems. The full carrier DSB wave has poor efficiency since the major transmitted power is concentrated in the frequency of the carrier components, which contains no other information. Only the upper and the lower sideband is something that carries any information. The total power transmitted in an SSB system is less than the total power in DSB. The percentage of power saving is up to 88.33 percentage. Okay. In the spectrum of an amplitude modulated wave, both the sidebands carry same amount of information, which makes it meaningless to transmit the same information on both the sides of the spectrum, which is a power based. This particular disadvantage is overcome by SSB technique, where you are transmitting only the required ones, all the other ones are eliminated. Not the required ones, we are transmitting only the single side band. I should not see you playing that. That is why there is an authorized person between you. If you have any of classmates, don't hesitate to ask. Okay. Shall we go to next? One class, one voice. Like fast. 3 more slides. Disadvantages. What are the advantages and what are the disadvantages? Naturally, you have enough bandwidth advantage. So what happens is that the system would be more complex. It is more difficult to generate and receive a SSB system when compared to a DSB system, because you are simply simply generating the signal, you are sending all the components in AM. Here you need to reduce the carrier component, you need to reduce the other one sideband, and so naturally it becomes complicated. The generation of SSB requires sharp cutoff characteristics. You need a better filtering characteristics. Receivers require more precise tuning than DSB. SSB receivers require carrier recovery and synchronization circuits which add to their cost, complexity and size. With this, we are coming to the end of the first half of first module. We have studied what is amplitude modulation and its basics. We'll have a review question. See, as I go on, I'll be discussing with you certain questions that had already appeared for GATE according to our syllabus. I've taken some previous year question papers in GATE for reference, and I wanted to discuss these question papers in the class. These questions. Questions based on what I have taught. Multiple choice questions as well as the descriptive questions. So while going through a previous year GATE question paper, I came across this question. So those students who are interested to prepare for GATE can also contact me. I'll help you on that. Which of the following analog modulation scheme requires minimum transmitted power and minimum channel bandwidth? I will be discussing certain multiple choice questions that had already appeared in GATE while teaching you a particular portion. This will be helpful for you to prepare for GATE also. The answer given is SSB, because the transmission of a single sideband modulated signal requires the same bandwidth as the original message itself and takes minimum power for transmission, as a carrier is suppressed. So the answer is C. The answer is single sideband systems. And you may know that DSB-SC, the two options B and D are almost the same. No, sorry. In AM you have the carrier also. Here it is suppressed carrier, okay. It is different. Double sideband suppressed carrier. Double sideband full carrier is amplitude modulated wave. This is a question that appeared in your exam. Derive the modulation index of AM wave in terms of Vmax and Vmin. Okay. So thank you all. Thank you very much for attending this session. Thank you very much.